Tumelang, Mulune, Sanbonani Kochai. Today we're going to talk about the work, energy, and power theorem. So, did you know that the word work can be used with different meanings? Yes, it can be used in different meanings as the word work. We use it in our daily lives and we say the word work and we refer the word work to someone maybe that is doing a job, and that's how we say he's doing a work or she's doing a work. And yeah, and then in physics, that is what we are going to demonstrate here today, the word work. So we're gonna start with the word work today, and you may forgive me about my writing and my voice today as I have a flu, so I'm shooting this video with a flu. So we're gonna talk about a work. So it's an interesting chapter, it's an interesting topic to talk about. So as I said, that in our daily lives, we use the word work when we are referring to maybe a job and stuff. But in physics, now, in physics, the word work has a definite meaning. So it has a definite meaning. So it means that it's different meaning compared to the one that we use in our daily life. So it has a definite meaning to the word work that is used in our daily lives. So as it has that definite meaning, it means that it's different meaning compared to the one that is used in our daily lives. So how do we see that it has that difference in it when it's compared to the word work that is used in our daily life? So we're going to demonstrate that today. Maybe I'm going to demonstrate that unto you today. So in today's video, let's consider the fact that there is an object. So here is an object, is small like a scenario. It's an object with a constant. So it's an object with a constant, force. We name that force as a force F. An object with a constant force of F that is applied, and it undergoes a distance or a displacement that is delta x. So it undergoes a displacement. So the displacement, in other words, we can use a distance in order for you to remember the word displacement. The displacement is the word that is used in physics, but it represents a distance. So it undergoes a displacement that is delta x, and then once we have a constant force that is acting on an object and a displacement that is delta x, that it undergoes when that force F acts on that object, it means that Those are the two parameters. Those are the parameters. Once we have those parameters, that is a constant force, that is F, constant force of F, and now the displacement and the displacement, or else at the distance, the displacement delta x, that x on that object, it means that a work is done on that object. The work is done on that object. Work is done on that object, on an object, because we have the displacement object, because we have a displacement and the constant force F that is acting on that object. So now, as you know that, I hope you heard what I said. We have a scenario whereby we have a constant force that acts on an object, and that object, when that constant force is applied, that object undergoes a distance, or maybe you call it a displacement. So the displacement here, I mentioned it as delta x. So it means it's a displacement, that object that undergoes when that constant force F is applied on that object. So those are the parameters that we need. Once we have a constant force F applied on an object, and we have a displacement, or we may remember it as a distance that undergoes an object when the force is applied. So a work is done on that object. That's the way, the difference between the work that we use, the work that we do in our daily lives, and the work that is demonstrated in physics. And now I'm trying by all means to elaborate that to you. So now we know that in physics we like to define something. So when we define the word work in physics, we're gonna define it in symbols. In this way, defining the word work. So when we define in symbol, so now we're gonna define it in symbol. So when we define this word work in symbol, we're gonna say that W is equals to F delta X. You see the parameters that I mentioned, and I'm gonna demonstrate also those letters that you see there in just a few seconds. And now we said here the parameters constant force F and the displacement delta X. So now we say here W is equals to F delta X cos theta. We're going to talk about the cos theta in just a second, so bear with me also. We talked about the constant force that is applied on an object, and we talked about delta x as a displacement that the object undergoes when the constant force is acting on that object. And then we have a cos theta. So now let me try and write what the letters mean here. So W stands for the work done on an object. So and the units that they carry with. So it's work done on an object, and then it is measured in joules. And we're gonna talk about the units for work. They are in joules, and you know that we have an energy Here we have energy whereby energy is measured in joules. So we're gonna talk about that because work done is equals to energy transferred. You're gonna hear that. So just bear with me. So now let's focus on F here. What does this F stand for? So this F stands for the force or the constant force that is applied, or you can say a constant force, or you're gonna say a force applied on an object. You can say force applied like that. So this APP there stands for force applied on an object. So you know something about Newton's third law, Newton's second law, Newton's first law. You heard something about forces. So the force is measured in Newton. You get me? Those are the units and they are important. They are important for you to remember. And now we have a delta x. We're going to talk and we're going to demonstrate each and every parameter that we meet here because they are important to understand. That's why I'm stressing this onto you. So delta x. Delta x stands for the displacement. Displacement. Or you can remember it by referring to it as a distance, because the displacement is measured in meters and the distance is in meters. So you can remember it as referring to it as a distance. And now we have the angle theta. So the angle theta here, as I said, that we're going to talk about the angle theta. So don't stress much about it for now. So let's focus on the ones that I mentioned. So the angle theta, I can just say to you, it's the angle for now. It's the angle between. So it's between what? It's between the constant force or the force applied and the displacement, the direction of the displacement. So I'm gonna say displacement here. Displacement. Yeah, you get what I'm saying? And it's measured in degrees. Sorry for that. It's degrees here. Yeah. So now let's talk about the fact that I said work done is equals to energy transfer. Are you up for that? To hear why the work done is equals to the energy transferred. So work done. Work done, I said unto you. So let's say here it's work done. Now, why the work done is equals to the energy transfer. So bear with me, and I said unto you that work done is measured in joules, and energy, if you can take a look at kinetic energy, energy is measured in joules. Kinetic energy is measured in what? In joules. So this one is measured in joules and this one is measured in joules. So they are equal. No, that's mathematics, gymnastic. They are equal because they are measured in joules. This one is the same as that one. And that's not the case for now because there is a better way to demonstrate this unto you. So, if you can take a look at the what we call it's thermodynamics, first law of thermodynamics. So let's say here, first law of thermodynamics. First law of thermodynamics. Of thermo, I will say thermo. Yeah. The first law of thermodynamics says that energy cannot be created or destroyed. Not destroyed, rather, it can be transferred from one object or form to another. So energy cannot be created nor destroyed. Not destroyed, but can be transferred from one object to another. So here, what does this mean? We are talking about the work done on an object. In order for a block, let's imagine this. We have a block here, a 3 kg block, 3 kg block with a mass of 3 kg. And you are trying to pull this block towards you. And the fact that you are trying to pull this object, it means that there needs to be an energy transferred from you in a form of power, and then it pulls that object towards you, and then it's transferred from you to another. And then once it gets to the object, it then pulls that object because the work done on that object is equal to the energy transferred. Once the energy is transferred from you to the block, and then you pull that object, you are able successfully, let me place it that way, successfully pulled that object towards you. It then means that the energy transferred from you, that is equal to the work done to that object, it means that you are successfully able to successfully pull that object towards you. So it means that whenever you are trying to, the energy that is transferred, the energy, since it cannot be traded or destroyed, it means that the energy that you used to pull that object, you transferred it from you to the object, and then the work is done on that object by pulling it. And then it means that the work done on an object, the work is done on an object when there is an energy transferred. So I left here is, forgive me for that, but let me write it neatly here. Work is done on an object. The work is done on an object when there is an energy transfer. When there is an energy transfer. So you have to transfer an energy in order for you to successfully do the work. You get me? You're trying to pull an object from one point to another, and you have an energy. in order for you to do the work. You get me? So the work in physics, as I said earlier, that is it's it has to have the parameter with a constant force F and a displacement. So here you are trying to pull this object from point A to point B. That's a displacement. The displacement. So here there goes a displacement. And then we're trying to pull. With that trying to pull an object, it means that it's a force applied. Those are the two parameters that you used. So when you are trying to pull that object, it means that you transfer energy from you because you have an energy. And then you transfer that energy, you trying to pull that object. And then that object move from that point A to point B. And then work is done on that object. By trying to pull it and you successfully transferred that energy and then you pull it towards you to point B and then work is done on that object. And then the take home message here will be work is done on an object when there is an energy transfer. You get me? Then energy transfer. Work is done on an object when there is an energy transfer. You get what I'm saying? That's why we have a work done on an object that is equals to an energy transfer. Energy transfer. You get what I'm saying? Transfer. Sorry for that. Then now we have an energy transfer. Since we have an energy transfer, then the work is done on that object.